Hey, what's going on there, folks? Welcome back here. Live stream, of course, is up and running. It is the Earthmaster out here on this Tuesday. It is Tuesday, March 12th, 2024, about 6:41 p.m. here, California time. Latest activity shows a 2.7 there into the Hawaii area. One of the latest quakes there on the globe. Looks like in the Hawaii area. Did see some further movement down into New Zealand here recently. Let's see if we can spot that Hawaii quake. Looks like that's going to be that 2.7 there on the Hot Caves Hawaii station. Looks like a slight uptick going on there across the area of Hawaii. Just going to cover some activity there in New Zealand. We've been chatting about New Zealand here recently with a bunch of deeper quakes here across the area of New Zealand. Not a whole lot showing up there on the USGS map because they only report 4.0 and above. But if we take a little trip over here across the EMSC model here, and we can see the last week or so of earthquakes, and it's definitely active, I would say, in terms of the deeper activity taking place here in this region recently. And that's a little concerning because, of course, the Hikurangi Subduction Zone does sit just off the eastern coast here of New Zealand. And it's been a little while since we've seen any earthquake activity out here in terms of a large-scale adjustment. Big-time earthquakes, talking about above 8.0. And there's even a possibility here with a full rupture being a 9.0. So these subduction zones are definitely subjected to very large earthquakes. I want to show you guys a little map here. Is it going to be this one? Let's see here. I think it's going to be this one right here. There's quite a few articles that are worth reading. This one was put out in June 2019 from the ScienceDirect.com site, chatting specifically about the subduction zone there, the Hikurangi Subduction Zone, or they call it the Hikurangi Subduction Margin there in New Zealand, has not produced a large subduction earthquakes within the short written historic period, which is about 180 years. And the potential of the plate interface to host larger earthquakes and tsunamis is poorly constrained. Now, they did do a study here recently, and they identified at least 10 past possible subduction zone earthquakes over the past 7,000 years. So just on average, if you want to know an interval, that's going to be about 700 years that they see a large rupture. The last subduction zone earthquake occurred at, looks like 520 to 470 years before present in the southern Hikurangi margin. And the strongest evidence for a full margin rupture is at about 870 to 815. So potentially could be getting close to being overdue for a full rupture, right? Of course, this is all subject to what goes on as far as slow slip events go and whatnot. They kind of chatted about here recently that the slow slip event out there that they see, similar to the Cascadia subduction zone, between a few years back, they had roughly the equivalent of about a I think it was about a 7.3 earthquake in the terms of slow slip events out here across this subduction zone. There is a 26% chance of an event with a magnitude 8.0 or larger striking beneath the lower North Island area of New Zealand within the next 50 years. So this is kind of the locked area right here. Let's see if we can bring up the other article. Obviously, there's many surface faults and whatnot up here as well, but we're talking about the Hikurangi Subduction Zone where it all begins. And, of course, underneath this area, you get down into the deeper areas of that subduction zone. The locked area is pretty much upstream here. Let me back out of here. You look at this, yeah, 9.0 range are thought to be possible. That's a little on the scary side here. Multiple uplift earthquakes will have occurred in the locked areas of the fault, but a good historical record does not yet exist. So multiple uplift earthquakes will have occurred in the locked areas. But right now, we got a lot of deeper activity underneath this region. Here is where they're mentioning the slow slip event here. Back in 2013 to 2016, there was quite a bit of tremor, slow slip event there into the area of the Hikurangi. Involved a moment release of approximately a magnitude 7.4 when you put all of these events together. So they believe here that it potentially prevents a big one from happening. But that slow slip event was a little bit further up along the northern section of the Hikurangi Subduction Zone. Unfortunately, with the lack of historic earthquakes, as far as keeping a record of it, it's a little on the questionable side on what to look for prior to it. If there's going to be big earthquakes or moderate earthquakes prior to a big one. It's similar to the Cascadia, although the Cascadia subduction zone there off the west coast of the states are a little bit more studied. And let's see here. There is a rich record of large upper plate fault earthquakes, and isn't this what they were talking about here? Seeing some of these quakes prior to a big one. 1855, a 8.2 earthquake. 1931, M 7.4 in the Hawke's Bay area, and the earthquake that happened back most recently in 2016, 7.8, Kaikoura, excuse me. The Kaikoura earthquake was a big one as well. So obviously it's demonstrated that at certain locations, upper plate fault earthquakes can cause coastal deformation, ground shaking, and tsunamis similar to the effects expected at the site for a subduction zone earthquake. But these are all minor, right? These are all just surface adjustment quakes going on across the area of New Zealand. So it looks like back in 2018, a survey identified a potential answer in Seamounts, huge underwater mountains that stretch from the ocean floor without reaching the surface. Reported in June, found evidence to suggest that fluids remain trapped in a trough made as seamounts pass their way through the subduction zone, allowing the fault to be weakened over many earthquake cycles. Quite a bit of, extinct volcanoes as well. I'm not for sure how to... is it Papaku Seamount? Is a long extent volcano lying kilometers beneath the seafloor east of the North Island, colliding with the subduction zone amid a pattern of stress fluids and sediments. New Zealand's in an area that has historically, a lot of dynamics to it. A lot. So I pulled up the earthquake activity here since at least the USGS records here of 6.0 since about the year 1000 or so. Largest one, at least, it doesn't look like they put on the 1855 earthquake. What was that? 8.2 somewhere out here. But quite a few sevens out here. The last, big event like this was back in 2016, as I mentioned, the Kaikoura earthquake up here. That was a pretty strong earthquake. Of course, this one here being more stronger towards the Christchurch area, 6.1 back in 2011. I remember this one as well. That was a dandy of a quake. And of course, anywhere along the plate boundary here, you can see some large earthquakes. But specifically, this is more concerning up here since we've seen deeper activity events here recently. And, the potential for an 8 and maybe even greater, up to a 9 magnitude with full rupture here is very possible. 1931, 6.2. There's really no distinct date as far as when the exact last event took place out here. As far as the last big one goes, there's studies and whatnot. There's talk of it being hundreds of years. Well, this is a huge article here, guys. Big article. I don't know if you want to read all that. I'm not going to read it all. But they're stating here the last subduction zone earthquake occurred 520 to 470 years. That was in the southern Hikurangi margin, and the strongest evidence for a full margin rupture is at 870 to 815. So when you do the math on this, 7,000 years of 10 possible events comes out to about 700-year intervals on average. Evidence for subduction zone earthquakes on the northern margin has not been identified because deformation signals from the upper plate faults dominate the geological record. So there's obviously some large uncertainties remaining in regards to evidence of past subduction zone earthquakes on the Hikurangi margin, with the greatest challenges presented by temporal correlation of the earthquake evidence when working within uncertainties of radiocarbon dating, right? Either way, we know it's there. There's a lot to study on this. Looks like, where was the average slip at? Displacement here is about 2.4 inches per year. Let's see what we got here. Displacement. That's just average here. So when was the last one? 800, and we'll just go 800 years, right? So you go 2.4 inches times that by 800 years. That's, wow. That's 1,920 inches. And divide that by 12. That's 160 feet of built-up strain. That's a lot. Well, subduction zone, that's quite a bit. Here's another displacement module right here showing 41 mm per year at this slip rate area. Things get, a little different as you go down here across this plate boundary. This isn't a subduction. This is obviously a strike slip fault, transform fault. Notice the arrows there sliding past each other. These red lines here going underneath this area are the subduction zone. It does look like there's more accumulated stress up here on the north because of the direct angle compared to down south here. But this is where they see a lot of the slow slip events taking place up here. And the more locked area is right up here in that region. Or I should say down here. Just right about here where that arrow's pointing. So there's definitely a lot. You could go on and on looking at this stuff. There's another photo on here. Let me see if I can find that one. Quite a bit of information here visually. Again, I'm not going to go through all of this. But I wanted to show you guys. They had a map here of where the locked areas are. Hopefully everyone's enjoying their Tuesday out here. I just want to jump on, spend a little time here on the live stream just to cover some events out here. It's not fear-mongering. This isn't fear-mongering. It's, if anything, it's information here. Low confidence. Let's see. There's so much. I don't want to go through all of this. Conclusions. Has a rich geological history, right? Obviously, there's a lot going on here. And, these mentions of years is on average. It could be another 200 years. It could be tomorrow. It could be tonight. Either way, there's a little bit of difficulty trying to, figure out exactly when the last one that took place out here. It's worth a read. ScienceDirect.com has a lot of cool articles on it. So the importance of a major research focuses on the role of slow slip earthquakes, which unfold along the boundary silently, yet pack the power to shift faults by tens of centimeters over days, weeks, or months. Their occurrence didn't mean necessarily that the Hikurangi's next big shake is on the way, with the vast majority of events transpiring without ensuing ruptures and often helping relieve pressure slowly. I guess that kind of makes sense, right? It is relieving pressure slowly across this area in certain regions. In other parts of the boundary, however, the plates are stuck or locked together and constantly building up pressure. So that's always been a thing. I've always been one to think of if there's tremor activity occurring, right? Slow slip event activity, and here they're thinking that it relieves stress. Wouldn't that add further pressure upstream if you're getting tremor activity downstream here in these areas? It would make sense anyway, because obviously tremor is a form of further strain out here against the plate boundary. I don't know. There's always just a little question about that. I kind of compare this to the Cascadia Subduction Zone where we see a lot of tremor, and recently we really haven't seen a lot of tremor. So does that mean things are building up or, calming down? So this is just another article here too. There's so much. Timothy here on the chat's probably got a lot of information on this as well. There's a lot of videos. A lot of people study this, but it's definitely of interest here. And like for example, the Cascadia Subduction Zone here, no tremors today. I don't think we had any yesterday. In fact, if you look at the general, let me bring this down a little bit. It looks a little bit too big. Look at the general tremor here across the Cascadia. We really haven't seen any major tremor events since the end of 2022. We had a couple smaller ones, but really not that much compared to past years where we've seen regular intervals of large tremor events. So the question is now, with this tremor activity occurring down 35, 45 kilometers underneath this area, let me pull up a little bit of data so you guys can see. Here's the last month with, this is the last month. Here we go. Bring that up. And even so, that's not really a lot of earthquake activity or tremor activity. 4,512 epicenters, mostly down here across the southern end. So think about that. The locked area, the strain area, sits right offshore here. Now, if this activity, slow slip, is relieving strain, what's going on up here across the subduction zone area of where it's locked? Wouldn't it make sense for when you see further tension down here, further slip, that it's adding strain and stress upstream? It just seems likely that that is the case. I never really understood that completely. But a lot of people think tremor activity, yes, it can accumulate to a certain magnitude over time, but the locked areas upstream, that tremor is not occurring on the locked areas. That's further down dip into the subduction zone areas underneath this region. So something has to be going on here across the locked areas. It's definitely an interesting study because we don't know. One of these days when the big one does hit, whether it's a Cascadia or out on the Hikurangi Subduction Zone, we'll be able to at least have this data to go back and look, see what transpired as far as tremor activity, see what happened as far as surface adjustment, and hopefully, use that information to predict the next big one, at least in the future. And that's it could happen anytime. That's the thing. And the activity that's been taking place there underneath North Island recently is just there's a lot of deeper quake activity underneath this region. Probably go back the last 2 weeks or so and see more activity. Most of it has been underneath this area. There's been one surface. This is a surface adjustment that was yesterday. That tells me right there that strain is building up here because we've seen a lot of deeper activity downstream here recently underneath this area, underneath the Bay of Plenty, underneath the North Island area, to where we're seeing further strain upstream in the locked areas of the Hikurangi Subduction Zone. I'm still waiting for some further movement down here, where the obviously where more of the strain's built up. It's been what, a little while. This earthquake 4-pointer came in today, another deep one, 92 kilometers underneath this area. So it's just it's very active. Nothing showing up right now across the New Zealand chart. Oh, I literally almost flipped my keyboard over. Gotta watch what I'm doing here. Make sure we're still live. I got a bunch of hotkeys set here, so I want to make sure I'm not gonna pull the plug on anyone. Let's see. What do we got? Yeah, this is the last 365 days. But there's quite a bit of deleted events in here as well. I'm going to check out the earthquake drums. There's going to be that 4-pointer recently. That showed up pretty nicely across the area. That's going to be it right here. That was about 90 kilometers deep there, more towards the south side of the North Island region. Some of these smaller quakes really can't see it. Some of the deeper ones really won't be able to see it either. But it's there. I showed you on the earthquake EMSC model, also up here on the earthquake 3D globe. There's just a lot of deeper activity triggering down here. And I said to watch this area, right? And we haven't seen anything large yet. But over the past couple weeks, we've had large events down here, 6-pointers. Bunch of movement up north here. Puts New Zealand right in the target area. And we're definitely seeing some adjustment, but not quite, in terms of the potential out here. Couple 3s, a couple 4s. Either way, that's some uptick. Whole bunch of earthquake activity deep underneath this region. Just kind of, keeping an eye on it. I would definitely be on guard for New Zealand for some further movement. It's just one of those areas that definitely looks like it's about ready to move further than what it's already doing. Let's see. Yeah, there's all sorts of stuff out here, folks, in terms of information regarding the Hikurangi Subduction Zone. Which I don't think most people are ready for. It's unfortunately that's something people need to just prepare for. Is this showing the locked area? Hold on a second here. I think this is the locked area that they were stating. White arrows with black outline indicate plate velocities, while the black arrows at the subduction zone plate boundary indicate trench normal, trench migration velocities. So yeah, just quite a bit of potential out here, folks. Kind of an interesting little site here. Story maps, neatly laid out. It looks like it provides a whole bunch of links there to some YouTube videos. But yeah, there's a wealth of information on here. I just think it's very valuable to be on guard and stay alert to what's going on out here. All right, so a little bit there on New Zealand. Let's check out Iceland, right? That's been another area of hotspot activity. Shows 130, right? up here on the map. The majority of these here are in the positive as far as like direct magnitudes, but you have to go over here to the negative events. I still don't understand what these are. Negative magnitudes, it's a little on the odd side. So I really am not looking at those right now. I'm more concerned about the original events. And there's definitely some swarming going on here south of Grindavik across the area of the rift boundaries. Not so much up north, but definitely confined here to the southern extent. Past 24 hours of earthquake activity out here. Doesn't really bring it up too much. There's a little bit of activity here across Grindavik. Again, that's in the positive magnitudes. And negative magnitudes, I still don't... not understanding that completely. Really no new update from the Icelandic Met Office, at least here on their one of their main sites. This was put out, it looks like about 5 days ago, and they still think that, you know, chances are high for an eruption, which they are. Things aren't going down. They're still consistently inflated underneath this area, so it's just a matter of time. See what's going on out here in Hawaii. Hawaii definitely looks a little bit more active here. Got a little bit of swarming going on. Looks like about 2 kilometers underneath this area. The latest one, the 2.6. So let's go see what's up here from the Volcano Hazards. Where the volcano currently still sits at a yellow and advisory. Hopefully it's going to work today. It looks like it is. Double check, make sure we're live. Everything looks good. No choppiness today, folks. Yeah, there was kind of weird stuff going on here yesterday with the stream. I don't think it was solar flare activity because we really haven't had any major solar flare activity here recently. I think it was just a couple user errors on my side. As far as the UWE tilt station here, showing the inflation at the summit. A little bit of decline here over the last day. Not that big of a deal. The last 30 days, obviously, we're still swelling a little bit, which shows a stair-stepping event. But we're still well below what we had seen prior to all that magma being displaced there at the summit a couple weeks ago now. There's some of the earthquake activity showing up here on the seismograph station. Not a big amount. How many times am I going to click it? That's it. That's my last time. It looks like there's a couple earthquakes here on the graph, but really not that much going on. And those earthquakes of, 2s and 3s are showing up there across the area. I still don't know why sometimes it does that. It's really weird. I would like to see this. Hold on a second. I don't know why it does that. You know what I'm going to do? I'm going to open this up here real quick and bring that browser back over here because it's something to do with the Google Chrome browser. I'm not for sure if I have something set wrong or what. But I've never had any issues here with the Edge site, Edge browser. This is the one I want to look at. Look at that sharp rise right here. You guys see that? Now, this is where the magma has displaced to. Off on the... let me back out here just a little bit. I don't want to make it too small to where you guys can't see, but it's going to be this station right here. It's a GPS monitoring station. Now, remember I've chatted about how all that magma got displaced from the summit off to the southwest rift zone and is now sitting down here somewhere. I think it's pretty obvious where it's sitting. Look at that. Look at that huge displacement here of since that magma got displaced there at the summit. Definitely some adjustment taking place right there. What that means as far as future eruptions, I guess we'll have to see. All I know is it's definitely down there. We watched a trail of activity, earthquake activity, start at the summit, and literally you could watch it heading off here offshore. Mauna Loa up here, fairly quiet. Of course, back in the eruption right there, we lost a lot of the summit. Well, not the summit, but the inflation. Looks like we're slowly going back up here. Really not a whole lot of earthquake activity here recently. Maybe a couple ones up there. So keep that handy, because this, for some reason, I don't know why it does it. It's so weird. Is it going to do it with the webcams here? Let's see. Yep. So I don't know. I'm not 100% certain why it's doing that. May have to go through and delete all the maybe the cookies or something, some JavaScript. I don't know, but it's a little irritating when it does that. All right, looking out here across California, fairly quiet. Yes, there's a handful of earthquakes out here. A little clustering going on here across this segment of the San Jacinto Fault Zone. Not a big deal. Not anything to look at in terms of major swarming, but just a little bit of activity here. These are all very small microquakes. Not a whole lot going on across the San Andreas Fault. One earthquake here that was mentioned in my update this morning on the San Andreas Fault, but for the most part, things look fairly quiet out here. And again, the Cascadia, not a whole lot going on there, but it's a sleeping giant. 324 years of built-up strain. And just, somewhat quiet out here. If you really look at the big picture of our normal zones, right? Normal being the western areas of the Pacific Plate where it's almost always active. We're lacking activity right here. I mean, you can pretty much draw a line there from roughly from about Papua New Guinea eastward here through Solomon Islands, Vanuatu, and up to right about here. Haven't seen nothing at all in the past few days. It's a little on the odd side. So while that is kind of quiet, we're seeing that adjustment down here across New Zealand. The deeper quakes take place here. And are we losing quakes off of this globe here? Looks like there's less and less earthquakes on here across New Zealand. What's going on here? Let's see. I think I have it set here for last 24 hours. Maybe right about... When was this last one? This was at last night at about 8 o'clock. So looks like it was just under the 24-hour threshold. But still, there was a couple more earthquakes down there, wasn't there? Where did they go? That's a little odd. Earthquakes disappearing right before my very eyes. And there's that 5.1 out here across the St. John's area, it looks like. But nothing showing up here on the USGS map. So let me go over and check out the EMSC model here. Yeah, see, they're reporting that earthquake right about here. 4.8. Looks like it did get downgraded here in the Leeward Islands area, again, north of St. John's area. Kind of like this map with the plate tectonic drawn into it. Get to see where things are. Although the Aleutian, I was like, the Aleutian Trench is not in there. Just kind of, I guess, how the page is set up. A little earthquake activity down in Australia, it looks like, today, 2.4. See what we got here for space weather activity. See if there's, oh, there we go, back down into the B flare. See that? B 4.4, goodness. But I'm getting excited because I think 3590 here is close to peaking around the eastern limb once again. This is the sunspot that produced the X flare activity, right? Last month there in February, quite a few X's, quite a few M flares. That is the sunspot right here on the far side. This is the Earth-facing side. So when this comes over here, we'll get a better view of it on the eastern limb. And it looks like this one's starting to get more advanced right here, but that's the sunspot that is currently off on the western limb now, 3599. Figures that it would start getting more complex as it gets out of view. I'm still watching this area right here, though. I've noticed this region growing here over the past couple days. So that's about the only one right now worth watching until till that former sunspot comes back around, and of course it will be renamed to a new sunspot. But it's still, the sunspot that has produced the largest X flare of this solar cycle, which was the X 6.3 from 3590. It'll come back around and bend about around the bend here in a little while. Yeah, this was back on February 22nd of this year. That was just a huge flare. X 6.37. And they can get definitely bigger than that. These, if you really think about, these flares are somewhat minimal compared to other solar cycles here. This is just, let's see here. Solar cycle 24 had an X 9.3 back in 2017. Quite a few large X flares there. So anyway, I mean, we're not done yet. We're definitely not done yet with the solar cycle 25. It's supposed to be peaking out here sometime in 2025. At least according to their original chart, which is this one right here. They did put out an experimental one, a revised one to match the current sunspot cycle that we're seeing right now. I mean, that seems like it's cheating a little bit, right? Let's adjust this to where, it's supposed to be a forecast. So this is the original forecast there, peaking out sometime in 2025. The revised one shows it peaking out sometime this year. It could be any time. But, we're still up there. Still up even above the predicted one, the original one. So we'll see what happens once 3590 comes back around the bend. Hopefully it can provide us with some more awesome flares. Hopefully. I got my fingers crossed. It still looks complex. Well, at least looking on this, it looks like it's still a giant sunspot. We won't know until it comes back around for another view. Any major severe weather going on out here? Doesn't look like it. Looks like marginal risk for some severe weather. I don't know what we got as far as current conditions out here. Let's see. Rain. Actually, we want to check out the weather radar here. A little bit of storms out there across Missouri. This is the area potential of some severe weather today. Looks like a huge unorganized cluster of thunderstorms out there. One lonesome supercell down here outside of Joplin. Rest of the country, some scattered activity out west, and out where I'm at here in the California area. We got some clouds, but that's about it. Not a whole lot going on here. And we're really not expecting much here in terms of storm systems out here. Even the next 10 days out here for California, look at that. Nada. Zip zero. We're supposed to be in the upper 70s to low 80s beginning. Oh, a helicopter just flew over. Beginning around this weekend, lasting into next week. So that'd be nice. Pacific Northwest, looks like these guys are going to dry out as well over the next 10 days. Here's where all the precipitation is going to be down in the southeast. Looks like some in the Four Corners area as well. There's definitely going to be a lot of colder air coming in with these systems. Looks like a bunch of snow coming in around the Denver area, Colorado, all through the Four Corners area, and of course the northern tier states up here as well, getting quite a bit of snow. Looks like the Alaska area as well. far as what's going on in terms of monthly outlooks, right? This was issued back in February 29th, the leap day. This was their forecast here for March. They show a huge area of above out here across the west coast, but that is not really playing out right now. That's for precipitation and our monthly temperature. And I guess it's just average, but we're supposed to be drying out. We're going to be below this as far as our average precipitation. March could be a wet month, but the forecast looks like it calls for not a whole lot of rain. And that's just the seasonal. If you want to look at 3 month, try to figure out what's going on maybe towards spring and summer. Let's see what we got here for April, May, and June. This is just a forecast here by the Climate Prediction Center, excuse me. I wonder if this is going to play out. Above temperatures here across the Pacific Northwest. Below precipitation out here as well. Looks like the eastern portion of the country much above there for precipitation. And that's for April, May, and June. Now as we get into the middle of summer, June, July, and August of this year, looks like the west is going to cook. And maybe some chances of some monsoon. It looks like maybe a monsoon of moisture will be funneling up here, because it does have equal chances of either above or below. That normally means that there's some monsoon of moisture coming up. But wet across the east, and these are just kind of an overall pattern of what the computer would spit out in terms of what to look for the seasonal outlook. It could be completely different, but you just never know. Either way, it's going to get hot. Summertime's coming up. It's going to be a warm one. All right, what else we got out here, guys? Anything going on the seismograph stations? A little spike coming in here to the Southern California graph. A little one there on the Hot Capes Hawaii station as well. Again, keep an eye on New Zealand, folks. It does, it's definitely more active down here than it has been in quite some time. And it makes sense considering all the activity we've seen around New Zealand here recently for that plate to make adjustment. But I'm not 100% certain that we're done yet. So we got to watch New Zealand. Keep an eye on these quiet zones here. These are major plate boundaries that are almost always seeing earthquake activity, but nothing in the past few days. Same for the Mariana Trench and the Izu Trench. So things are just super quiet in those zones. 3.9 coming in off the coast here, Costa Rica, it looks like. I mean, look at that. When was the last time you seen the USGS map look like this out here across the western areas? It's been a while. Goodness. All right, folks. So once again, I'll just, if you guys get a chance to read these articles, it's definitely worth it. This is just a lengthy one. But if you want to know more about it, this describes into detail, scientific detail as well, about all the past earthquake activity there in New Zealand and the potential of some much bigger earthquake activity there along the Hikurangi Subduction Zone. All right, we'll catch you guys back out here a little bit later tonight, folks. Okay, have a good one. Stay safe out there.